Hello. Hello. I think we'll start soon. Hello. I'm trying to figure we're live yet. So, can you guys see me? I'm curious. Oh, yes, now it's working. That's me. Hi, everyone. How are you? Okay. Well, I'm very happy to welcome you to our show. I'm actually in the middle of teaching a class right now. We're teaching a class means having dinner with my students. But I'm very happy to be here to welcome all of you. I want to make sure that we have this straight. I want to see, is Xin Zhao here, the contest manager, the center manager for Math Kangaroo? Let me quickly ask. Meanwhile, I see that people are here. So tell you what, let me just go and say the welcome because we got two different ones running at the same time. And if Xin Chao joins this one later, then of course, then the introduction still applies. But first of all, welcome everybody. Welcome to the live solve. We're very happy to collaborate with Math Kangaroo USA on this because we love their problems. They're very creative. And to help to bring all these questions to life, we have some of our extraordinary stars, Elma and Jennifer, who are going to be leading this live solve. But what I will say first, during my part here, is I just want to say welcome also to the representative from Math Kangaroo, who should arrive at some point in this. Her name is Xin Zhao, and she's a resident of Blacksburg, Virginia. She's been involved with Math Kangaroo for over 10 years, beginning as a center manager, and she currently works on math. She's a biostatistician in clinical research. She's also the parent of two children, now in middle and high school, and they've participated in Math Kangaroo since first grade. So she brings both professional and personal passion to the Math Kangaroo program. But I'm just going to welcome everyone. It's a great thing to come, and please do come every first Sunday of the month. We're always happy to have you. With that, I'm going to pass it over to, let me quickly ask, is Xin Chao here? If so, you're on. If not, in that case, then I'm going to bounce it over to Elma and Jennifer. You guys are all in good hands. Take care.
Thank you, Professor Lowe. So welcome everyone to our live solve for Math Kangaroo. And I think we can get started by introducing ourselves. So I'll first start by introducing Elma. So Elma is a high school senior and a devout follower of the Yellow Pig and number 17. As a hardcore mathematical modeling enthusiast, she obtained a meritorious award in the HIMCM 2021 and regional finalist in IMMC 2022, and has authored at least 3 research papers in applied mathematics. So that's very impressive. Alma also got into the top 1% of the AMC 8 in 6th grade for competition math and qualified for the Amy in 2022. In her daily life, she builds a fantasy world of characters, draws digital art of them, and writes their stories. Alma also enjoys hosting and playing Mafia/Werewolf in online forums. So say hi to Elma, everyone. I'm very excited to be teaching with her today.
And hello, everyone. And I see that there's one of my students yesterday who was actually in this chat. Oh, also a big shout out to Anna, who is here, and you're very fun in class yesterday. So let me also introduce Jennifer. So Jennifer is a high school junior from Indiana. She is an Amy and MP4G Olympiad qualifier and attended the G2 math program in 2024. And in 2022, she placed 36 at the national math counts. Oh, right. So, maybe it's because of the flow of time is different because a certain rat is in chat. I am not a high school senior and Jennifer is not a high school junior anymore. Oops. But anyways, 36 is a good number. It's a square. She also co-founded the Infinity Squared Mathematics organization, and in her spare time she enjoys crocheting and listening to music. I always want to learn how to crochet, but I remember the last thing I crocheted was a donut.
That's pretty good.
Anyways, everyone, let's give a warm welcome to Jennifer.
And thank you for the warm welcome, Elma. And as you probably noticed, there is a bunch of messages popping up here. And to get your messages to pop up here, you should message to a certain person called Chat Relay. So if you go down to your chat, you can click on someone named Chat Relay, and hopefully your messages will pop up a few seconds after you send them.
Yay! Wow, everyone is so good at this. You're all pros of Chat Relay. Everyone is sending so many messages. Hooray! Well, do we say let's get started with the live solve since, or do we wait for the special guest to show up?
Is a special guest here?
I don't think so. Are they? I don't think so.
Well, then I guess without further ado, we can start with the first question. So our first question here is, each of the cards shown below has two 3-digit numbers written on them, but some of the digits cannot be seen as they are covered in ink. On one of the cards, the sum of the digits of both numbers is the same. And on which card are those two numbers? So as you can see, we have five cards here with two 3-digit numbers on each, and some of these are covered up. So my first idea here is to look at the sums of the digits that we already see here. So let's first look at this first card. I see 543. Oh, sorry. I see 543 and 1 something. So what I immediately notice is that 5 plus 4 plus 3, 5 plus 4 plus 3 is equal to 12. You can't really see that. Sorry, it's a little hard to see. But 5 plus 4 plus 3 equals 12. And then I see a 1 plus 1 plus something. So 1 plus 1 plus something should also equal to 12. That means that something would equal to 10. But we know that each of these digits that are covered up are going to be 1, 2, 3, 0, 1, 2, 3, 4, up until 9. So 10 is not allowed, and we can get rid of that option. Now, for the second option, we have 5, 8 something and 1, 1 something. So if we have 5 plus 8 plus something equals 1 plus 1 plus another something, well, now we have 13 plus something equals 2 plus another something. So that means that their difference is going to be 11. So this might be a weird way to put it, but there's two question marks are for a different thing. And we know that the difference between two single-digit numbers it can't be a 2-digit number, 11. So we know that this option doesn't work either. Now looking at this option, we see 9, 8, 2, and 1 something something. So 9 plus 8 plus 2 is going to give us 19. And 1 plus these two digits are going to be 1 plus two unknowns here. And that means that the two unknowns will sum up to 18. So the two unknowns will sum up to 18. Now that means that these two can just be 9 and 9. So we found one that actually works. If this is 982 and 199, we see that 9 plus 8 plus 2 equals 1 plus 9 plus 9. So we know that this one is possible. And we could check the other two, that D and E don't work. But since we already found out that works, then we can just move on and check our answer. So, would you like to check our answer?
Yeah, let's go. So, for the next one, it's 2, 1, 1, and 6 something, right? This one's a little bit weird since, well, let's just do the sum of these three numbers first. So it's 2, 1, 1. It's 2 plus 1 plus 1. That's 4. Correct me if I'm wrong. So that's 4. And here we already have a 6. So unless these two are like -1 or something, which it does not work as a digit, it's not gonna equal. And for the last one, we have 777. And okay. And here we have 2 something something. Ah, there's a mosquito. Okay, fine. But so let's just add this up together. I guess that's 3 times 7, that's 21. And that's 2, so which means we have a leftover of 19 stuffed inside these two digits. And we know if one of them is 9, which is the biggest digit, the other one has to be 10, which does not work as its digit. Fine. It's the mosquito again. But still, with the help of the mosquito and also with calculating all these numbers, we found out that these two are pretty much impossible. So we double checked and made sure this is the answer, and we actually know precisely which number this is. Yep.
Yeah, so let's check our answer now. And yay, we got our answer correct. So it was this one, so C. So let's move on to the next question.
And for some people, you might ask like why we are the first question is not question 1. It says question 17. Yeah, I know 17 is the best number and totally deserves to be the first number inside all of the numbers, but we are trying to solve the questions that we find particularly challenging. So if your question doesn't show up, it's maybe it didn't pass the rat check, but we are happy we love all of the questions. Let's go on to the next one. Okay. We have some boxes. Let's see. So, we have a person named Henry who wants to write a 0 or a 1 in each cell of the diagram so that the sum of numbers in each row, column, and diagonal is 3. He already has written a 0 in one of the cells, and when he finishes, what will be the sum of the numbers in the cells where the question marks are? Wow, this looks like some kind of magic square, but usually magic squares, they don't have the same numbers filled in. But this one only has zeros or ones. Let's see what the 0 does. So, we have the 0 here. This means it says the sum of all the rows, columns, and diagonals is 3. So if we already have a 0 right here, then what else is inside the zeros row or diagonals? Well, it's just, as someone said, just fill everything in. So everything else must be 1, otherwise the sum can't be 3. So, yeah. Basically this. So then we have the question marks. And the question marks are each on columns as well. Let's see. If you can all see, this column is green. This column has 2 ones and 2 question marks. And if you can see the pink one right here, wait, that's the wrong column. Oops. LOL, might have. Anyways, I can just shift it down. It's the column underneath. Yep, that one. So that's the column with the 2 question marks. So we can see in this green one that we have 2 ones and 2 question marks. The pink one also has 2 ones and question marks. We don't know which one exactly is the 0 and which one is the other one, but we do know there's some, right? It has to sum to 1 because, well, yeah, so there's either a 0 or a 1 somewhere in here. And in here, there's also a 0 or a 1 somewhere. So I'm thinking the answer is 2, right? Since, right. Jennifer, would you like to check for us?
Yeah, so I also think that the answer is 2. Like Elma said, there has to be a 0 or a 1 between these two, and also a 0 and a 1 between these two. So if we add 0, 1, and 0, 1, we should get 2. Maybe we can check our answer now. And we got it right. So yeah, thank you for the explanation, Elma. Now we can move on to the next question. All right, so for this question, it's covering up maybe half of my face, but it's okay. We have a witch that has 10 apples, 9 bananas, and 6 pears. It's a lot of fruits. And one day she performed some magic and turned each of her pieces of fruit into one of the other two types. For example, she changed each apple into either a banana or a pear. She now has 15 apples, 7 bananas, and 3 pears. How many of the apples did she change into bananas? All right, so this question is kind of mind-boggling in my opinion because you have to kind of think about not only that you switch apples into either bananas or pears, but which ones did they switch into? So I can see that all 10 of these apples are going to switch into bananas or pears. And that means that there has to be out of the remaining out of the remaining 7 bananas and 3 pears, 10 of them were originally apples. Well, that means that there's 10 total fruits that changed from apples, and there's 10 total fruits that are apples at the end. So that means that all 10 of the apples correspond to all 10 of the other fruits. So in that case, I just think that the 9 bananas originally and the 6 pears originally all turned into apples, which correlates because 9 plus 6 equals to 15, which means that 7 of the original apples turned into 7 of the bananas. So since we want to know how many of the apples she changed into bananas, I think the answer is just 7. What do you think, Elma?
Yeah, I think so. That's a very easy answer. But before we reveal, our secret guest has arrived. So, let's welcome our California State Director from Math Kangaroo, Mr. Ravi Kiran Karanjkar. Sorry if I butchered the name because, well, please tell me if I pronounced it wrong. But, well, he is the engineering manager at Amazon who exemplifies the perfect blend of professional excellence and community dedication. And as the California State Director of Math Kangaroo, he has been instrumental in fostering mathematical thinking among young minds like you through innovative, gamified teaching approaches. Beyond his corporate role, Mr. Karankar's passion for educating extends to running a nonprofit school that helps students maintain strong connections with their cultural heritage and mother tongue. His unique teaching methodology, which progressively builds from fundamental concepts to advanced problem solving, has inspired countless students in their STEM journey, and that's all of you. Mr. Karanjkar is currently expanding the Math Kangaroo competition program while continuing his role as an official faculty member. Wow, that's brilliant multitasking, and thank all of you for the applause. Let's welcome. Well, let's see where he is.
Hey, hi everyone. Can you hear me? Hey, Alma, if you could help me unlocking my video, that would be great.
Yeah, let's see. So, let me try. So, it says put in waiting room. I think it's something with perms of like everyone. So, allow
Okay, that's fine.
participants. Oh,
If
okay. Okay, I think you can do it now, right? Can you?
Yes.
Oh, great.
Hey, hi everyone. Great to see you all. I see there are 100 plus participants into this meeting and then two wonderful hosts. I'm really happy that you all registered for this event. You have been taking your enormous efforts while upcoming our individual competition is coming in 2026. But some of you already know, but it's an exciting news for many of you where we have come up with a team competition as well. So if you're not aware, work with your center managers, find out the centers around. I know this time we're trying to do this as a pilot project this year, and slowly we'll expand this further in upcoming years. But this being our first year, we would like to get you all participating in our team competitions so that you can form your teams, create your camaraderie with your grade level up or down so that you can get into the competition. So competition registration has already started and it will continue throughout this month. We are looking forward to get your registrations and get your feedbacks after the exam is done. I'm also happy to see that this year registrations are going up for our regular individual competition. Many school districts are allowing their respective students to go ahead and participate, and maybe we'll be able to get some schools ranked higher depending upon how many ranks they're producing in their schools. So I'm really excited for what Math Kangaroo is doing. We are breaking the tradition of doing only individual competition for more than 28 years. And this year we're starting with two competitions. And maybe down the line, we plan to have more and more engagement with all you students so that you don't have to wait for us just once in a year. So looking forward for your wonderful registrations, great exam, and creating the Math Kangaroo community. Thank you very much. And I'll let Emma and Jennifer continue on the respective problem solving. If you have any questions, don't hesitate to reach out to us either at info@mathkangaroo.org or Ravikiran at mathkangaroo.org. I would be more than happy to help you, support you, and create STEM as well as all the mathematics specific interest among all the students. Thank you, everyone.
Yeah, thank you so much. So thank you so much. And as Ravi Kiran Karankar, sorry if I butchered that too. As he said, you can go contact him or email him at the emails that he provided. So yeah, and back to our live solve. So we got our answer as E for this question, and now we can go check it. And drum roll, please.
Check it.
And the answer is 7. So yeah. Next question.
Okay, so next question. Wow, why do I always get the block related questions? So we have the person named Joanna, who divides a figure like this into 5 equally shaped parts, each consisting of 3 squares, and the square containing which letter is the same as the square with the star. So, let's see. It says 5 shapes, identical shapes. So it's very funny how like we have no square here and we have other places all having squares. It looks like a 4x4 grid, but it is not. So we need to divide the grid into 5 parts that look equal. And maybe some people thinking, what do the parts look like? So intuitively, if we have 3 blocks, then we just place them like this, right? So we just have something like this. And then we just this one has to go like this, and then we divide, and then we find out that we couldn't include the star anywhere since, well, if we just do this, then some blocks will be broken off. So this does not work. This means the blocks have to look something like this, because that's the only other way to arrange 3 blocks into a shape. So what does it look like? Well, we can go back to this part, this outcrop. That, well, then it only can go into a shape that looks like this. Well, at least we have C out of here. And for the other two, if we put it like this, then we can only like have it here, and then the last two here will not have a group to be in. And that's, well, not the best, I guess. So we have to go with this one, facing right as well. And this outcrop will go here. And hooray, I think we just divided it. Yep. So now, which one is in the same shape marked with the star? Well, if you can look at this neon orange part that I've drawn here in orange, can you see it? So it has a star inside, and here it has the letter E. So I'm guessing it's the letter E that's gonna be put in the same little weird wonky shape with the star. Am I right, Jennifer?
Yeah, let's check. And yeah, we're right. So it was E. So the key to that question was to notice that it's not going to be 3 blocks in a row, but rather 3 blocks in a little L shape. So that was a nice, cool problem. We can go on to the next problem now. Oh, this one's a large grid. So Julio, I'm not sure how to pronounce that, but he wants to construct the cross shape shown in the picture using pieces shaped like the ones below the cross. He has many copies of each piece, and the pieces can be rotated if needed, but they cannot overlap. What is the smallest number of pieces that Julio could use to construct the shape? So, we have this really cool looking diagram. I'm going to actually make it larger so we can see it better. But I see that we want to find, in the question, it's asking the smallest number of pieces that he could use to construct the shape. So what my first idea is going to be taking the largest sized shapes in order to get those out of the way, and then we could fill in the last pieces with the smaller shapes if needed. But that way we can get the smallest number of shapes. So I noticed that this shape right here in the rectangle is quite large. So I feel like I'm going to be using that one a lot. And also pretty large are these shapes here, and then this shape too. And then this shape is the smallest. So if possible, we want to avoid using this middle shape. But let's see the diagram now. I see right here that there's these little parts on the cross, the ends of the cross that are kind of sticking out. So how can I tile those so that we can get the least amount of shapes? Well, I see this, oh, sorry. I see this shape right here and this shape right here. They can be put in here and here to completely cover up this end of the cross. And if I do that for the other side as well, then I can use those to completely tile the ends of the cross. And then in the middle, I see that I can use this yellow rectangle right here to tile like this. And then in the middle up here, up and down, we can use that same reasoning. Oops, yes. To tile it like this. And now we just have another one of these at the bottom, and then 2 little triangles left over here. So if we just use these 2 little triangles, and then do the same thing we did on the other sides, like this, oops, then we should get a nice little configuration here. So let's count how many pieces we used. So we used 2 of these triangle things. And then how many yellow ones do we use? 1, 2, 3, 4, 5. Five of the rectangles. So 5 rectangles. And then let's see, three of the parallelograms. So 3 of these things. And then also 3 of those other triangles, the larger triangles. So Yeah, in total we use 2 plus 5 plus 3 plus 3 equals, I believe, wait, sorry, 13. We used 13 total. And let's see if that was an answer choice. Yep, that was an answer choice. So our answer is C. Alma, would you like to check that?
Yeah, so I also drew another configuration that is also valid. It's that you just have 4 branches looking the same, and the middle one you use a square, and it's also 13. So it's not the only way, but it is a smallest way. And let's check. Oh, this is just another image. Yay! It's 13. Hooray!
Hooray!
Okay, so let's move on. Wow. The squares do love me more, right? Okay, so Patricia, I'm assuming that's the name of a person, wants to write the numbers from 1 to 9 into the squares of this peculiar diagram. She wants the sum of the numbers in any two adjacent squares to be equal to the numbers shown on the line joining these squares. What is the sum of the numbers she writes in the shaded row? So I'm thinking that it's gonna be quite hard to see what is in the shaded row. So I am gonna make it bigger and draw it on. The shaded row is here. So it's, let me know if you guys can't see clearly. It's here. I'm putting it inside this neon green color. It's here. It's these three. So let's see. It kind of looks like the first problem, right? The first number sums problem. So we have a 9. We have a 10 here. And here we have an 8 and an 11. Let's see which part has the smallest numbers. So we know that there's gotta be a 1, right? It's 1 to 9. And we know that 1 added onto any number, it's gonna make either a single digit number or a 10. So let's see where the 1 is supposed to be in. Well, it cannot be here since it has an 11, and 1 plus 11 means we have a 10. So the 1 must be here. It's a 9 and a 10. So that means this part must be 9, because otherwise where did the 10 come from? And this part is 8. And then we can start solving from here. So I'll use a brighter color so we can see on the shadow what it's supposed to be like. So this is 9. I'm hoping you can all see the red. Yeah, that's great. And since this is 8, there's 12 here, which means this one is the 4. And we check 9 plus 4 is indeed 13. And since this is 4 and the sum is 9, this is going to be 5. I'm drawing a really big 5 over here. And if we check that, here's 5, there's 8. This one is going to be 3. And 3 plus 8 is indeed 11. We can try to fill out the grid in its entirety if we really want to. But that just gives us another double check, and we already have all the answers on this row. So what is 5 plus 4 plus 9? Let's see. Everyone is saying C. I see from Jennifer's screen that C is 18. And indeed, 5 plus 4 plus 9 is 18. Should we check?
Yeah, we should totally check. So the answer is 18. So yeah, thank you everyone for putting your answers in the chat and confirming that our answer of 18 was correct. So let's move on to the next question. So Sarah had 3 times as many chocolate bars as Sanaz. Sarah then gave a quarter of her bars to Sanaz, and Sarah now has 6 more bars than Sanaz. How many more bars than Sanaz did Sarah have originally? This question has a lot of S names in it, so maybe I should abbreviate them. And we want to know how many more bars than Sanaz Sarah had originally. So we can we can make them variables. So let's call the amount of bars that Sanaz had originally as A. So A equals how many number of bars that Sanaz had originally. And then B is going to be the number of bars that Sarah had originally. So actually, we know that Sarah had 3 times as many chocolate bars as Sanaz. So we can already write that A times 3 is going to equal to B. And then now Sarah then gave a quarter of her bars to Sanaz. So that's going to mean that, sorry, this looks like a 13. But Sarah then gave a quarter of her bars to Sanaz, which means that she has 3/4 left. So now that she has 3/4 B, she now has 6 more bars than Sanaz. And Sanaz is going to get that 1/4 B. And Sarah still has 6 more bars, so we add 6. And then we should get these two equations here. So we see that 3 times A is equal to B. So yeah, so A plus 1/4 times 3 times A plus 6 is going to give us 3/4. Sorry, it might be cutting off a little bit, but it's going to equal to 3/4 times 3A. Now we can solve for A here, and we get A plus 3/4 A plus 6 equals 9/4 A. So 6 is equal to 2/4 A. So that means A is equal to 12. That means that Sanaz had 12 originally. And then we see that we remember that Sarah had 3 times as many chocolate bars as Sanaz originally, which means Sarah has 12 times 3, which equals to 36. So we want to know how many more bars than Sanaz Sarah had originally. So we just take 36 minus 12 to get our answer of 24. So yeah, should we check our answer, Elmo?
Yeah, let's check it. So this was one of the difficult questions. We had a lot of algebra and not numbers. Oh yeah, it is 24. Yay!
Yay! All right, let's move on to the next question.
And now we have grade 7 and 8. We have this problem. It's a very interesting shape.
Also, I can't tell its shadedness.
Yeah, I can't either, but I think it's these ones since we have like a small pattern here. So I'm thinking it's these. So it's in the yellow that I'm drawing. It's a symmetrical shape. It's kind of pretty. Yeah, this one. So it says what fraction of the hexagon is shaded? So by, let's see. I'll put it here. So as we often teach in life, there is one method that is very important to us, and that is called intuition. And if we want another word for it, guesswork. But anyways, let's just count the number of triangles. We have, I'll use a high contrast color here. Wait, I can turn it blue? Nice. So now it's blue, I'll count in orange. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 triangles. And by intuition, or just guessing, we know that all the little triangles here have the same area. I mean, well, they do look the same, so let's say they're the same. Also, it's just question 4 anyways. It's not going to be a lot harder, right? So, let's just see how many triangles there are in total. And since we don't want to count all of it, that's just boring and inefficient, we can split the entire shape into 4 parts. We have the left part, we have this part, and then we have these 2 parts, and we can just count one of them. So let's just count one of them. We have, I'll delete the little triangles here. So, oops. Actually, stop chewing on my bid paper. Okay. So I'm deleting this, and it's only the leftmost part. So we have, let's count with me, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the total is 9 times 4, that's 36. And then we just divide it, and 12 over 36 is 1/3. That's the rough way. And shall we check it?
Yep, I think we should check our answer. That seems about right to me. So let's check. And the answer is 1/3. So yeah, thank you, Elma, for explaining that. And let's move on to the next question. All right, this one looks like a logic question. So there are 10 more truth tellers than liars in a room. Truth tellers always tell the truth, and liars always lie. Everyone in the room was asked, "Are you a truth teller?" And everyone gave an answer. A total of 20 people answered yes. And how many liars are in the room? So what I notice here is that the key part of this is that truth tellers always tell the truth and liars always lie. Meaning that when you ask a question, "Are you a truth teller?" we know that truth tellers will say yes. And then liars will also say yes, because obviously they're not a truth teller, but they won't say no because they lie, so they would say yes. So that means that everybody would say yes. So if we see that there's a total of 20 people that answered yes, that means the total number of truth tellers and liars is going to be 20. So now we know that T plus L is equal to 20. So we also know from the question that there are 10 more truth tellers than liars in a room. So we know T is going to equal to L plus 10. If we substitute that into our equation here, L plus 10 plus L equals 20, meaning that 2L is equal to 10, and that means L equals 5. So there are going to be 5 liars in the room. You want to check our answer, Alma?
Yeah, of course. Yay, it's 5.
Yay!
Hooray. Hope the answer is not lying. So, now we have a sports problem. There are 5 hurdles in a 60-meter hurdle race. The first hurdle is 12 meters. The gap between any 2 consecutive hurdles is 8 meters. So how far is the last hurdle from the finish? Well, let's see. So, let's have the first hurdle here, and that's 12 meters. And between any consecutive hurdles, there are 8 meters. So how many hurdles total are there? There are 5 hurdles. So these are the hurdles. 1, 2, 3, 4, 5. I'm making the hurdles green so we can see them better. These are the 5 hurdles. And the race is not over once you jumped all the hurdles. There's also like the final part where you have to get to the finish line. And so we want to know, what is this? And we know that the entire thing is 60. So basically, it now boils down to finding out what's 60 minus 12 and then minus 4 times 8. We know 4 times 8 is 32. And this is 44, correct me if I'm wrong. And then 60 minus 44, well, just to be sure, 60 minus 44, 6, yeah, it's 16. So it should be A, right? It's 16 meters.
Yep, let's check our answer. And indeed, it is 16 meters. So, yeah, thank you to Elma. Let's move on to the next question. Okay, there's a little shaded circle here, and we see that Edgar wants to write a number in each circle in this diagram. So he wants each number to be equal to the sum of the numbers in the two adjacent circles. He has already written two numbers as shown. So he's already written 1 and 2. And what number should he write in the gray circle? So what I noticed first is that he wants each number to be equal to the sum of the two numbers in the adjacent circles. So immediately we can figure out what this number in the top circle is, right here. This is going to be 1 plus 2, or 3. Now we see that 3 plus this circle right here is going to equal to 1. And this is only true if x is equal to 1 minus 3 or negative 2. So this number here is going to be negative 2. Now we have this number in the shaded circle plus 1 is going to equal to negative 2. So that means negative 2 equals x plus 1 here, and x is going to equal to negative 3. So that means that our number here is going to be equal to negative 3. And if we wanted to, we could also check it from the other side. Elmo, would you like to check it from the other side?
Yeah, so from the other side, we have negative 1 here, since, well, 3 plus negative 1 has to equal to 2. And then indeed, we have negative 1 equals to negative 3 plus 2, and negative 3 equals to negative 2 plus negative 1. So if it loops back, then it's probably right. Is it?
We should check to find out. And it is negative 3. So, yeah. Let's move on to the next question.
Yeah, so I know that a lot of the problems we've solved are using brute force or assumptions or something, and that is valid because probably in the Math Kangaroo competition you're running short on time, and there's like so many problems here, and for the first few problems we really don't want to spend a lot of time on them. So sometimes it's just best to trust your intuition. And so here we have another sport problem. And this is actually the last problem that we have here, right? So Warren is on a treadmill in the gym. He keeps looking at two stopwatches. The first shows the time elapsed since he started the session, and the second shows that the time remaining until the end of his session. Ooh, interesting. So let's see, let's draw a timeline in case it's confusing, because it's kind of confusing me. So start and end. Let's suppose Warren is here. So he is here. So one of them shows this time, and the other shows this time. So it says at some point the two stopwatches show the same reading. What did they show at this time? Well, this looks like something like an average, right? So it's basically at this point in the middle, the distance or time here and the time here are equal. But when exactly can we make a average of times? So the first one, I'll just say it's 14h plus 58s. The second one is plus 65m. Okay. Like, wait, is it minutes? Or is it like, oh, it's hours and minutes. Okay. That's also fine. Plus 32 minutes. And we want to find what's midway between them. We add both together and divide it because that's how we find the average. So there's 14 plus 21 over 2 plus h plus 58 plus 32 over 2m. And then we run into a problem because here, as we can see, this is not a whole number, so we get like something not very whole h. So that's 35 over 2, which is 17 plus a half h. And over here, well, we got a nice whole number here. And then we have, over here we have 58, that's 90, right? And then we have 45m. Jennifer, please correct me when I'm wrong. Mental math is not my strong suit. But I see that 58 plus 32 is 90, so half of it should be 45, right? And then we can say, well, of course, it's 17.5 to 45. Do we think it's this? Oh, wow, that's my favorite time of the day. 17.5 hours.
Yeah, me too. That's totally an option here, you know?
Yeah, so, well, since the answers kind of disagree with us, I don't see 17.5 in the hour section. Oops. So, let's go back. We assumed it as some kind of number in which h and m are the variables. But now we know that h is actually hours and m is just minutes. And we know that, so if we treat them as something like meters or kilograms or something, or whatever you do in physics that have you convert between different units, we can see that 1h equals 60m, right? So 1h is 60m. Then we can get rid of the 0.5 in here. So 0.5h is 30m. And now we can just get rid of this. So we just turn it into 30m. And now we have 17. That's fine. And we have 17h and 75m. Wow. That's my second favorite time. I'll meet you guys at 1775. Right?
Yeah, what a wonderful time.
Okay, that does not work. Seems like something clearly has gone wrong here. Now, before we have a decimal hour, which we do not want, now we have a minute that's clearly bigger than 60. And so we can go back to this. 1 hour is 60 minutes, so 60 minutes is 1 hour, and we see that this one has gone way bigger than 60, so we can just take 60 away from it, reverting it back to 15, and add an extra hour to it. So now it's 18 hours, 50 minutes. I hope this is the correct time.
I hope
Is
so
it?
too. That is an answer choice, so it's answer choice D. Let's see if this is correct. And it's correct. So yeah, all of that work was for 1815 to be our midpoint time, kind of. So yeah, I guess that concludes our live soul. So thank you everyone for joining in today. And Ella, do you have any last words?
I'd say to everyone in Asia time zone, happy Mid-Autumn Festival, and to everyone in US time zone, happy early Mid-Autumn Festival since it's gonna be tomorrow. But be sure to go outside. Maybe not at 1775, but go out and watch the moon because it's gonna be very round. And have some mooncakes or cheesecakes. Yay!
Yay! Also, the moon will also be very bright, so be aware of that when you go out and watch the moon.
Yeah, just
But
as Cindy
yeah,
said, 中秋快乐.
中秋节快乐! All right,
Yay!
but thank you
Wow.
everybody for joining today. You guys are free to go now if you would like. Bye.